students. So in this experiment we are going to see about the Porter governor. So the aim of this experiment is to determine the effort, power, sensitiveness, frictional resistance of the given Porter governor. So before going to the experiment, we need to understand what is a governor. So a governor is a device which is used to control the speed of the vehicle at a constant rate. So with respect to variation of the load, the speed of the engine must remain constant. So that is the function of the governor. So how is this achieved? So this is called the Porter governor. So I will be just explaining you the parts first. So initially, okay, so there is a bevel gear setup, so which is run by the engine crankshaft. Okay. So this is connected to the spindle which powers the unit. So this is called the sleeve. The sleeve is able to move up and down due to the centrifugal force produced by the fly balls on either ends. So there is a central load which keeps the sleeve in the position. Okay. So now the sleeve is able to move in upward and downward direction due to the force, centrifugal force created by these fly balls. Okay. So this sleeve is in turn connected to the bell crank lever mechanism, which will control the throttle valve. So the throttle valve is the valve which controls the air fuel mixture into the engine. So now we will understand how does this work. So see, as the load on the engine increases, so normally the speed of the engine will, load decreases on the engine, the speed of the engine will increase. Okay, so the speed of the engine will increase, in turn the spindle speed will increase. So which will in turn increase the centrifugal force produced by this fly ball. Okay, so the centrifugal force will also increase. The sleeve will move upwards. Right? So once the sleeve moves upwards, what will happen is the throttle will come down. So there is a reduction in air fuel mixture supply to the engine, thereby balancing the speed. Okay, so the speed will remain constant. So now if the load increases, what will happen? Load of the engine will increase, the speed will reduce. So this will in turn reduce the centrifugal force produced by the fly balls. So then the sleeve will move in downward direction, the throttle will open to increase the air fuel supply so as to maintain a constant speed. So that is how the Porter governor works. So with this, what is the apparatus that we require to carry out the experiment? A Porter governor and a tachometer. So a tachometer is a sensor which is used to find the rotational speed, okay, in RPM. So what are the observations? So we have two fly balls, right? So the mass of each ball is noted, so which is small m. So in our case it is 0.35 kg. So then we have a central load here. So the central load is here. So the mass of the central load is 2.25 kg. So the dead weight is 1.5 kg. So therefore the total weight will be denoted by capital M, which is the sum of central load and dead weight. So that is 3.75 kg. So then we have the length of each arm, that is 0.125. So this is the arm, right? So this is the spindle, these are the arms. Okay, so the spindle is given by the engine, as I told earlier. So length of each arm L is given by 0.125 meter. So the initial height of the governor H is, so this is the initial height of the governor. So that is given by 0.085 meter. So then we see the formulas. So you can see, so the same diagram I have written here. So here we have the fly ball. Okay, so at point P. So this is the top arm, this is the sleeve arm. Okay, so we have a rectangle triangle here. Okay, whose height is h. So then we have up to the sleeve it is small h. So then we have the distance r. So that is called the radius of gyration from the center spindle to the fly ball center. That is radius of gyration. Then the length of the arm is 0.125 meter. So here we will see the formulas now. So C1 is h minus x by 2. So where x is the sleeve lift that is produced. So that we determine from the experiment. So then from the diagram, right? So take this triangle BEC, right angle triangle BEC. So what is that? So you have BEC. So this angle is θ1. So here you have the fly ball. Okay. So this is the L arm length. S1 is the distance. C1 is the distance on this side. So we have the formula sin θ1 is C1 by L. So S1, how will you calculate? Square root of L square minus C1 square. So the radius of gyration from the diagram you can see that it is R plus 0.05. Right? That will give you the value of radius of gyration. The height h is given by R tan